function. It's calling for us to solve a trig equation, right? So we're looking for some solutions. The variable is x here, and so you can see that the first line, right, for this is to, well, you could do this algebraically. You could square root both sides, so tan x equals root of 0.87, but I'm going to switch to a graphical method. Now you can solve any equation by graphing the left hand side, graphing the right hand side, and finding the intersection point. Right, so I'm going to do this graphing in two different ways. First of all, let's go and insert a graph. Insert a graph. So I'm going to draw tan squared x, but when I type in tan from the trig menu here, tan, it opens up a bracket. There's no space to put the squared, right? So we've got to put tan x, but then we've got to square the whole thing, right? So tan squared x is tan x multiplied by itself. Okay, we go ahead and graph that. Now notice I'm in radians here, so you've got to be super careful because this says negative 180 to 180 degrees. So we're actually going to go and change that to deg. But you can barely see any differentiation here in terms of the curvature, right? That's because of you've got 10 degrees here. So the best thing to do is just go ahead and change the scale straight away, all right? Now you can double click negative 180 and double click. I like that. But if you can't grab it, you can go through the full menu, window zoom, window settings, and look, x is negative 80. I like to tab through the options and then type in 180 and then tab instead of using the down arrow and then pressing enter. So that's it. Now go and graph the right hand side, which is 0.87. So on here just press tab, opens up the function bar, 0.87, and can you see there's four solutions there, right? So there's four solutions, so we're just going to go to the actual calculator, menu, analyze graph, intersection. Click on the left. Now if you drag over, you can actually get two at a time here, right? So look, you could even write that down. That's 136.99. That's actually 137 to 3 sig fig. And the next one is 43.01. So that's 43.0 to 3 sig fig, yeah. But then you kind of run out. But you can get them all in one go, right? Menu, analyze graph, intersection, click, and go ahead and close your hand and just drag it down. Menu, analyze graph, intersection, you're probably going to guess, yeah, it's symmetrical, right? This technically is an even function because if I put x value or negative x value, I get to the same height. So tan of x equals tan of negative x. So we call it an even function because you can see that line of symmetry down the y-axis. So can you guess what the final solution is? Yeah, the final solution is 137 as well. Okay, so I hope that helps. You can graph anything, graph the left, graph the right, off you go. Now for us, the intersection points were at a manageable height. Okay, now we weren't bothered about the height of 1, we were just bothered about the actual value of, the height of 0.87, right? 0.87 was the height for all of them. That's because that was the right hand side of the equation. Now imagine that this value on the right was 200 or something. You'd have to rescale the y-axis. So another popular way of solving this is actually to make subtract 0.87 from each side. Alright, so that would leave a 0 on one of the other sides. So what we could do then is if we dock insert a new graph, this time instead of plotting tan squared in two different graphs, plot one graph. So this is tan of x all squared, subtract 0.86, and now we're looking for the zeros of this graph. Menu, window zoom, window settings, negative 180, tab, 180, tab, enter. And can you see, look, 1, 2, 3, 4 zeros. And of course, menu, analyze graph, 0. You can see that we have the same solutions, although that's a slightly different solution because, can you see, instead of 0.87, I've put 0.86. So let's go ahead and change 0.86 to 0.87. And look, the answer automatically updates, 136.993. And here there was 136.993, yeah, negative. Right, so that's two ways of doing it. You either just plot the left-hand side, plot the right-hand side, find intersections, or you do a tiniest bit of algebra. You bring everything to one side equals 0, and then you're finding the zeros. And you can see the advantage of this method is you're only ever searching along the x-axis for the solutions.